Okay, so I'll share some questions, some past paper questions from the chapter circles. So I am going to share the PDF. Okay, so Saneem, I've shared the PDF. Just let me know once you're able to see it. I've shared it. Can you see the screen?
I can see.
Okay. Let's just read the question first and then we'll see how to go about it. So it says, in the diagram, the points A, B, C, D lie on circle 1. Okay, that's obvious. And A, E, C, F lie on circle 2. Okay. A, E, B and D, F are straight line. Okay. EBC is 73 degrees and AEC is 146. They have mentioned those angles. We need to calculate ADC. Okay. So we need to calculate this angle exactly, ADC. This one. Okay. So do you have any idea about this, Saneem? Any guess? Just a
I
guess.
think we have to ignore the bigger circle and consider the small circle only for this.
Okay, very good. That is a good strategy. So I'll zoom in just so we have the smaller circle. Okay. I'll try rubbing the pixel using the bigger circle. Okay, yeah. Now just imagine that you have the circle only. Okay, so what do you see? I'll rub the internal parts as well because that is also creating confusion. So just think about it this way. That's a very good idea. Yeah. Now, what do you think? No idea? That's completely fine. I just want you to think on your own as well, and then I would share the solution. Okay. Now we discussed cyclic quadrilaterals. What was the hint? That
I
all
was also thinking a cyclic quadrilateral,
hmm,
but for E, C, D, A, E and A are not touching the circumference.
no, look, the thing is that A is touching the circle 1. Yes, you're certainly correct. E is not touching the circle. But what do we have? We have to think about A, B, C, D. A, B, C, D is a cyclic quadrilateral. And think about it now. Yeah. So what is the property that we have? We know that the sum of opposite angles in a cyclic quadrilateral is what exactly? It is 180, right? So
Okay,
since,
so 7.
yeah, angle D plus B, since they are the opposite angles in a cyclic quadrilateral, what is a cyclic quadrilateral? Any four-sided figure whose four corners are touching the circumference of the circle. The sum of opposite angles is 180 degrees. We have B, okay? So D would be 180 minus 73. That means that it is going to be how much, Sunny? 107. Very good. So it would be 107 degrees. Very well done. Okay. Now I will get the circle back and then we'll talk about the next part. Okay, so Johan would not be attending this class and Rania is joining. I'll share the recordings with other students. Okay, this is the drawing, right? And we have calculated this angle to be 107 degrees. Okay. The next part says you need to calculate CFA. Okay, CFA. That is this angle. Think about it again. CFA. Again, I will use your strategy. That is a very good idea. I'll rub the extra parts and then we'll talk about the solution. So I am going to remove the circle. We do not need this. We are on circle 2 right now, so there's no point of having circle 1 and CFA. So I'll rub this as well and this too. Yeah. Now think about it. Again, the idea could be same, right? Always think about a cyclic quadrilateral whenever you have something inside the circle. Yes, it looks like it is not a cyclic quadrilateral, but this is first corner, this is the second one, this is the third one, this is the fourth one. If you think about AFCE, right? AFCE has all the corners touching on the circumference. So this is a cyclic quadrilateral. We are going to use the same property that was 146 okay, since this is a cyclic quadrilateral, so we know that sum of angles E and F is going to be 180 degrees. Okay, so 146, E is 146 plus F equals 180. You'll make F the subject, and what are you gonna get? You will get F as 34 degrees. This would be 34 degrees, right? Yes, Saneem, is this okay?
Yes.
And yes, Sarah, did you understand this?
It's fairness.
All right, okay. Let's talk about the next question now. Okay, here's the question. This is the second question. What exactly it is? A, B, and S are points on a circle. Yes, that is obvious. Center is O. T, A, and AB are tangents. Now, this is extremely important piece of information because we can think about that kite theorem which we discussed yesterday. ATB is 52 degrees, okay, and we need to find the angle AOB. So we need to calculate the angle AOB. So either it is going to be this angle or it is going to be the exterior angle. You can find both. Both are going to be correct. Okay, you would see both the answers in the marking scheme, right? Okay, this is what you need to calculate. So how do we calculate this? Okay, I'll help you with this, right? I have a message. Very good. Excellent. Very good, Saneem. Okay. The idea is that the angle between the radius and the tangent of the circle is 90 degrees. Okay. Now, what is this? This AOBT is a kite. Okay. It is a quadrilateral. It is a four-sided figure. Sum of angles inside this quadrilateral would be 180 multiplied by n minus 2. This is the formula that we use for finding the sum of angles. N is the number of sides, that is 4. This is the first side, the second one, the third one, and the fourth one. 180 into 2, that is 360. And now I'm going to do 360 should be the sum of angles for A plus O plus B plus T. So 360 minus angle at A is 90 degrees, minus angle at B is again 90 degrees, and angle at T is 52 degrees. And that is going to give you the angle O. That would be 128 degrees. So this angle is 128 degrees. Any confusion, Zara? Did you understand this?
It's clear.
All right, very good. Okay, please be honest with yourself. If you're not able to understand this, ask me. Okay, you might not be able to understand these if you have not done this on your own, because we have discussed the theorems first and now we are doing the past paper questions, right? Okay, I'll rub this and think about the second part meanwhile. Now we have to calculate part B, that says angle OBA. That is easy actually. I will rub this 128 as well because it's taking too much space. Okay, so I got an answer from Saneem already. Very good, Saneem, excellent. Okay. So this angle turned out to be 128. Now, if I think about AOB, it is an isosceles triangle, and this side is same. Very good, Rania. So that means this angle and this angle would be same, right? So 180 degrees equals 128 plus x, and you have to make x the subject and you would get the answer. Very well done, excellent. Okay, so yeah, that is the thing. And then it is ASB. You need to calculate this angle. Yeah. Any idea about this one? You guys are going really good. Think about it.
It will be the half of 128, 64.
Very good, both of you. Excellent. Very well done. Angle at circumference is half the angle at center. Very good. Okay. So I don't need to explain this question. Let's talk about the next one. Basically, today there's some problem with my laptop. That is why I'm not able to write properly. So I'm using another one. Okay. This is the next question. This one. Okay, I'll zoom in now. Okay. So A, B, C, and D are points on a circle with BD as the diameter. TD is a tangent at D and TDA is 36. You need to calculate the angle ADB. Yes. So I'll mention the angle. We have to calculate ADB. So I got one message already. This is the angle. Okay, so I got two answers and you guys are saying 54. Very good. Why 54? Because the angle between the radius or the diameter and the tangent is 90 degrees. So this angle would be 90 degrees. 90 minus 36 would give you 54. Very good. What about ABD? ABD. What about this angle? Yes. Okay, I'll tell you. So basically, for calculate, the hint is for calculating B, you need to calculate the angle at A, and you can calculate that. We discussed a property for this. So focus this at this point and this point. We have an arc that is being made. This arc, it is related to angle at center and angle at circumference. Okay. Now this arc is being made by this angle and this angle as well. Angle on a straight line is 180 degrees. Yes, can you hear me now?
Yes.
Okay, I'm sorry about it. All right, so I'll share the questions again. Right, so I've shared them again. You would be able to see that. Okay, so we were on the second part, ABB. And yes, I would agree this is comparatively difficult. In order to find ABT, you need to find angle A, and then you'll use the formula that sum of angles in a triangle is 180 degrees. Why is angle A 90 degrees? Okay, so we discussed two theorems. First theorem was that if we had a triangle of this type, that one of the side was the diameter and the opposite angle was being made at the circumference, this was 90 degrees. Okay, I discussed this property, I guess, yesterday or day before yesterday. And if you don't want to think about it this way, you can think about it this way, that angle at center is 2 times the angle at circumference, right? Or angle at circumference is half the angle at center, whatever way you want to think about it. So we have 54, we have 90 degrees. So 180 minus 90 minus 54 is going to give you the angle at B, and that would be 36. So this is going to be 36 degrees and ADB is going to be 54 degrees. ACD, what about this angle? Who's going to tell me?
This will also be 36 because same segment.
Very good. Okay, very good. Because the angle B and angle C, they are making the same arc, right? So we know that these angles would be same. Excellent. Rania, did you understand this?
Yes.
Okay, very good. Okay, now we discussed this type of a thing yesterday as well. Okay, so we need to find X, Y, and Z, and we know that in this diagram, ABCD lie on circle, center is O, AOD is the diameter, OB is parallel to DC. Okay. Now, first thing is always remember, whenever you have been told that two lines are parallel, if not this, then this, that you have arrows, right? You should know that they are parallel. Always extend these two lines and then you would get a better idea about it. So I'll extend this line. So this is the line OB and this one is DC. Okay. Yeah, now we can think about it. And we need to find the angle X. Okay, that is easy. This is the center. So we know that this would be the radius and this would also be the radius, right? This becomes an isosceles triangle. So this angle would also be X. So I got an answer, let's see, 20. Very good, Rani, excellent. Okay. So sum of angles in a triangle is 180. We have 140 plus 2x degrees and x is going to be 20 degrees. Very good. Okay. This is x. What about y? How do we calculate the angle y? Hmm.
180 minus 140.
I have a message. No, y is not 40. The thing is that again you're using the same thing. You are using the properties of cyclic quadrilateral, but this isn't a cyclic quadrilateral, right? I told you earlier as well. This is not a cyclic quadrilateral. For it to be a cyclic quadrilateral, all the four sides should touch the circumference. Okay. Okay, that's okay. If you're not able to find that, let's find all the other angles that we have. Okay. So let's see. You'll see this question would make its own way. So this has turned out to be 20. This is also 20. Okay. Then the angle, this is 180. Or think about it this way, that this is the diameter. This diameter is one of the sides of the triangle and the opposite angle is being made at the circumference at this point. So this is going to be 90 degrees. That means the angle ABO would be 90 minus 20, that is 70 degrees, right?
Yes.
Okay, that's good. And what about this angle? It is going to be 40 degrees.
40.
Very good. Okay. And what about this one? Sum of angles
70.
in a triangle. Very good. 70 degrees. Okay. Now we need to think about this angle Z. And we certainly can think about it using the concept of two parallel lines that are being cut by a transversal. I'll try extending this. Okay. So let's say I have two parallel lines and they are being cut by a transversal line. So what do we know? This angle is 20. What would be this angle? Okay,
20.
this angle is 20. This angle is going to be what? Just think about it this way, that this is the line and this is the other line. If this is 120, then the angle at Z is going to be, it would also be 20, no?
Yes, it will be 20.
It should be 20. Very good. So I'll write it down. It is also 20. Okay. And then yes. Now we can calculate the angle Y very easily. Now you can think about those concepts, the cyclic quadrilateral thing.
Y will be 110.
Very good. Because the opposite angle is at A, right? And what about T? That's also very simple now. Yes, again the same concept. So angles, opposite angles in a cyclic quadrilateral, they give you 180. This angle is opposite to this angle, right? So if this is 40, 20 plus 20, if this is 40, this whole is going to be 140. So 140 minus 70 minus 20 will give you 50. So 50 is the answer, right? Did you understand this, Rani and Sini? Please be honest with yourselves and tell me if you did not.
Miss, how did you get 20 at Z?
Okay, I'll explain this, don't worry. There's some issue with the laptop because I'm not able to write properly. Are you still able to see the screen?
Yes.
Okay. I'll make this diagram, the parallel lines and all that on this side, and that would help you with the understanding. So we have the line OB. Let's say this point is O and this point is B. And then we have another line that is parallel to it. This point is C, and then this one is D. And then I have a line, we call this a transversal line. Think about it as straight line. I'm sorry about this today. Okay. And these are the two parallel lines, right? So this angle is 20 degrees. Now, we have two parallel lines. What would be this angle? We know that the interior angles are 180. So 20 plus, what would be 180? This would be 160. And then we know that the sum of angles on a straight line is 180. So 180 minus 160 will give you 20. So this angle is basically the angle at Z, right? This angle. So that is why it is 20 degrees. Did you understand this now?
Yes, okay, thank you.
Okay, welcome. And what about you, Salim?
Yes, I did.
Okay, let's talk about this one. This is the last question. Okay, I'll zoom in a bit. I'm really sorry about this inconvenience today. Basically, it's because of my laptop. I'm using some other laptop today, so I'm not comfortable with it. Okay. So it says, in the diagram, the circle center O passes through A, B, and C. AC is a diameter. Okay, just stop here. Just stop here, okay? Let's not read the question. So far, I guess we did 3 questions in which we had a diameter. That was one of the sides of the triangle, and the opposite side was basically on the circumference. So what would be angle B?
90 degrees.
Very good. Okay. So by now we should understand this, that if we have a triangle, this was a property, that the longest side that we usually call the hypotenuse side is basically the diameter. So this would be the 90 degrees angle. Okay. That is good. Next thing is that we have been told that ACB is 34, TA is 3, TC is 5. We have all that on the diagram as well. Find the angle BAC. So we need to calculate this angle at A. This one. This is very easy. What would be this?
56.
Very good. 180 equals angle at B, that is 90, angle at C, that is 34, plus angle at A. And when you will make A the subject, yes, Tanya, what are you getting as the answer?
56.
Very good. Both of you. Excellent. And then the second part says, calculate the radius of the circle. So what would be the radius? Yes. I'll give you 2 minutes. Think about it. And then if you're not able to do it, I'll do it for you. Okay.
I used the Pythagoras theorem in this, and
Hmm.
for the whole diameter, I got 4, and the radius will be 2 then.
Okay, so you use the Pythagoras theorem. All right, very good. And what about you, Rania?
Yes, I can't figure it out.
Okay, that's completely fine. Okay, look, this triangle ACT is a right angle triangle, right? This side is 5, this side is 3. Why do I know it is a right angle triangle? Because the line TAS is the tangent line. So as soon as you read this word, just mention this angle, that the angle between the diameter or the radius and the tangent line is 90 degrees. Now this is your right angle triangle. You have two sides, 3 and 5. You can use the Pythagoras theorem to find AC. Let's write it down as X. So we know that according to Pythagoras theorem, AC square, that is X, plus AT square, that is 3, equals 5 square. So X square would be 5 square, that is 25, minus 3 square, that is 9, and X is going to be 4. So this whole length, the length of AC is 4. We were asked to figure out the radius, so it would be half the diameter. So 4 by 2, that is 2. This would be the answer, right? This would be 2 and this would also be 2 because radius is half of the diameter. So in short, the idea is that you can never ever count the number of theorems we have discussed, because it could be that in your schools you have learned less theorems, with me you have learned more, or vice versa, because we do not have an exact count of these theorems. You can make as many as you want to for your convenience, but every other theorem is linked to the previous one, right? Okay, always remember, you guys are quite good at this already, but some things that I would like to add: a triangle whose biggest side is the diameter, and the others, like all the sides, are basically touching the circumference. In short, an inscribed triangle, you can think about it that way, right? What is that? The angle would be 90 degrees. That means this triangle is going to be a right angle triangle. I repeat, in the fifth question and in two more questions that we have discussed today, the idea was that we had a triangle and three of its corners were touching the circumference of the circle. If one of the sides of the triangle, or in short, the longest sides, is the diameter, always remember that this angle would be 90 degrees. Number one, so as soon as you read such a thing, start finding out if you have this angle or not. If you have it, just make it 90 degrees. Then forget about these parts. Never ever read them first. Always use the data given in the question. Figure out as many things as you can and then think about the question. Yes, that might waste your time at times, but if you come across a difficult question, you need to calculate all the other things and then think about the solution. Okay, and I told you yesterday as well, these questions would be for 1 mark only, so even if you forget the reasoning, that's completely fine. Number two, whenever you see that XYZ line is a tangent, just mark the 90 degrees angle between the radius or the diameter and the tangent, right? So now I have told you about two 90 degrees angle. One for the triangle whose longest side is the diameter and three corners are touching the circumference, and when you have the tangent line, right? Other than this, you know all the other properties, all the other theorems that we have discussed, that if you have same arc that is being made by two angles that are at the circumference, like this one. So here this arc is being made by the angle C and the angle B, that is why they are same. And then the biggest thing, the angle at center is twice the angle at the circumference, right? So again, you can think about it either this way or this way, that this is a triangle, three of the sides are touching the circumference, this is the diameter, so this angle is certainly going to be 90 degrees, right? So that is it. Anything that you have not understood in this chapter, please tell me.
It's all clear.
Okay, because I am going to take a test on Sunday, inshallah, from this chapter, right? And when I say this chapter, I mean angles, because we need to practice as many questions as we can, right? There would be a test only from this chapter, right? From angles. Is that okay? You have 3 days. Since we have very less time for the exam, so now is the time that we start preparing everything. Okay. Forget about
Will it
what
be
is it. Yeah.
circle theory or only angles?
Yeah, angles के अंदर I'll ask about the circle as well. मतलब सर इसी तरह circle के अंदर वो parallel lines आ गई थी, and we have triangles as well, right? So you can
Okay.
think about that, and I will obviously give you past paper questions, okay? So I won't be asking you for definitions and stuff like that. I'll share the timings with you. Like I'll discuss the timings first, and then I'll give you the test, okay? So that is it for today. I'll stop the meeting. And I'm really sorry about the inconvenience. I was not able to explain properly because of my laptop. But yeah, that is okay. It can happen sometimes.